Hi everyone, as promised, this video is on how to calculate volume ratio for different gas phase reactions. The questions before you all have been said to be gas phase reactions. I have just written down the chemical reaction, and we can calculate the volume ratio, or some people refer to it as volume expansion coefficient, just from the stoichiometry itself. The stoichiometry will be given to you. You may often be asked for a very short marked question just to calculate the volume ratio. So let's start. First, what was the formula of volume ratio? Epsilon A equals to V of XA equals to 1, that is at complete conversion, minus V of XA equals to 0 by V of XA equals to 0. What you need to do is, when XA equals to 1, that is the reaction is complete, there are only the products. So what is the number of moles of products? 3 plus 1. The stoichiometric coefficient here is 1, right? So the total number of moles in product is 4. So that is what you write. Minus moles of reactant present when XA equals to 0, that is there has been no reaction occurring. So what is the number of moles? 2 by 2. This is 2 by 2 equals to 1. So that is my volume ratio for this case. Let's see what's the volume ratio for the second case. Epsilon A. See, I'm not writing down the formula again. 1 plus 1, that is 2. That's the number of moles when the conversion is equivalent to 1, minus 1, because in reactant species, when there has been no chemical reaction occurring, the number of mole was 1, by 1 equals to 1. In the next case, there is a bit of a trick here. You see, there is it said that there has been 20% inerts in the initial composition of the reactant. That means A plus inerts, let it be defined by I, is present. Okay, that gives you B. So it's very clear, first of all, that say if there is 10 moles of this entire mixture, okay, A plus I, then out of that they are saying 20% inerts. That means 8 moles of A and 2 moles of I. 20% inerts of 10 moles is 2 moles of I, and 10 minus 2 is 8 moles of A. Okay, so after conversion, see here the stoichiometry is 2A gives B. That means whatever amount of A we produce, we supply, we get half of that as products. Okay, what does that mean? We obtain 4 moles of B. This is the clear-cut thing for us. So now we'll utilize this deduction to calculate our volume ratio. So what are the total number of moles in the reactant side? Total moles of reactant is, say, 8 plus 2, 10 moles. No issues with that. Now what is the total moles of product side? See, product we are getting 4 moles of B from 8 moles of A. No issues with that. But remember one thing, the inert doesn't take part in the chemical reaction. Okay, so A is the only one who is reacting, and I comes out as it is with B. So it becomes 4 plus 2, that is 2 for the inert part, equals to 6 moles. I'll repeat again. When we are doing the reaction using inerts, the inerts do not take part in the reaction, so they come out with the product as it is. Hence we are taking in consideration the number of inerts that we have supplied. It is the same as it is coming out with product, so we are getting 6 moles of product. Now utilizing the formula, we may write moles of product minus moles of reactant by moles of reactant. That will give you minus 4 by 10, that's minus 0.4. This is your volume ratio for this case. In similar ways, you may be provided with different variations of the inert concentration, and you will have to solve it in this method. So that is it for now. Thank you.